Seed production in sugarcane. Non-availability or limited availability of quality seed of improved sugarcane varieties to sugarcane growers is a huge drawback in improving the production and productivity levels in the country. Stem cuttings or sets are the seed used in commercial sugarcane planting. Each set may contain 1, 2 or 3 buds. Annually, about 10% of cane that is grown is utilized as seed material. The quality and quantity of the seed used determines the performance of the crop. Keeping all production conditions constant, only an improved sugarcane variety with good quality seed can increase cane yield to a considerable extent. The Sugarcane Breeding Institute, Coimbatore, has developed numerous excellent varieties of sugarcane in India. Since the release of its first hybrid cane, CO205, many of the popular sugarcane varieties have lost their yield potential. The phenomenon of such gradual loss of yield potential has been termed varietal deterioration or varietal degeneration or varietal decline, and may be attributed to several factors including disease, insects, drought, soil condition, salinity, waterlogging, and monocropping. Poor seed quality has been identified as a primary factor affecting varietal performance. Establishing seed nurseries adjacent to planting locations and producing quality sugarcane seed is the key to realizing potential productivity. Therefore, a 3-tier nursery program is a must for every sugar factory in order to maintain a constant flow of good quality seed material of improved sugarcane varieties. Under the 3-tier program, heat-treated sets are planted for multiplication as primary nursery seed, followed by secondary and commercial seed, from which healthy, disease-free seed materials are supplied to farmers for commercial planting. The 3 stages in the seed production process involve the primary, secondary, and commercial nursery. Each stage or tier takes a year for completion, after which the commercial seed cane is made available to the farmers. In the first stage, the seed cane of varieties received from research stations as breeder seed or belonging to a healthy crop of suitable age is used to raise the primary nursery. The seed cane is first subjected to heat treatment and treated with fungicide before being planted for production of primary seed. The nursery crop should be nurtured with good nursery management practices and meticulously monitored to maintain it free of mixtures, diseases and pests. Normally, the primary nursery is raised in sugar mill farms. Harvesting is done at the age of 6 to 8 months. In older varieties with viral infection, tissue culture raised virus-free plants are preferred for raising the primary seed nursery. In the second stage, seed material collected from primary nursery or foundation seed is distributed to selected progressive farmers to raise secondary nursery. This is also maintained and monitored like the primary nursery to keep it free from diseases, pests and mixtures. Harvesting of seed crop is taken up at the age of 6 to 8 months and the seed material is distributed to farmers for raising commercial seed nursery. In the third stage, commercial nurseries are raised from the secondary nursery seed and are monitored likewise so that good quality seed is made available to farmers. Heat treatment will render it free from disease for about 5 years. Therefore, a well-planned scheme to replace seed once every 5 years must be devised. The whole operational area can be divided into 5 sectors and 1 sector may be covered each year so that the seed is replaced with rejuvenated seed once in every 5 years. If all sugar mills in our country follow this 3-tier nursery program and provide good quality seed of improved varieties to farmers, the average yield per hectare can be raised by 10 to 15%. Good quality seed is to be ensured through seed cane following certain criteria. Its age at harvest should be 6 to 8 months and 8 to 10 months for sowing in the tropics and subtropics respectively. The seed cane material should be reasonably clean and undamaged. Each node of the seed cane should bear one sound bud, and the number of nodes without sound buds should not exceed 5% of the total number of buds per seed cane. Also, the number of buds which have swollen up or have projected beyond 1 centimeter from the rind surface should not exceed 5% of the total number of buds. There should be sufficient moisture in the sets, and in general, the moisture content should not fall below 65%. The seed material should be free from the incidence of pests and diseases. Generally, farmers take only the top one-third portion of the matured cane for preparation of sets. However, this is an undesirable practice, and it is advised that seed material be obtained from nursery crop between 6 to 8 months of age. Good seed should have more than 85% germination. For controlling diseases, the seed cane treatment before planting will be effective. Heat therapy involves heat treatment at a temperature that kills the set-borne pathogens and impairs their vital functions while causing no detriment to the sugarcane. Hot water, moist hot air, and aerated steam treatments have proved effective in eliminating set-borne infection of grassy shoot and ratoon stunting diseases. Hot water treatment consists of immersing sets in tanks containing hot water, treating them at a particular temperature for a specified duration. 2 types of hot water treatments are currently being used. The long hot water treatment involves treatment at 50 degrees centigrade for 2 hours, while the short hot water treatment occurs at 52 degrees centigrade for 20 minutes. In the aerated steam treatment, the sets or cut canes are placed in trays and kept inside the chamber of the unit. Steam and air are mixed together and passed inside the treatment chamber, and the sets are treated for 1 hour at 50 degrees centigrade. This system is very effective against grassy shoot disease. At each stage of planting, it is essential that sets be treated with fungicidal solution to prevent the attack of soil-borne pathogens, particularly fungi. The sets required for 1 acre planting may be soaked for 5 to 10 minutes in 100 liters of water containing 50 grams carbendazim, 1 kg saturated lime, 1 kg urea and 200 ml malathion. The fertilizer application for the nursery involves applying NPK at 275 is to 62.5 is to 113.5 kg. In this, phosphorus is applied as basal dose, and nitrogen and potash are applied in 3 equal splits along the cane rows in furrows and covered immediately and irrigated. 1 month before the harvest of the nursery cane, 50 kg nitrogen and 75 kg potassium can be applied as additional dose. This enables quality nursery cane with higher glucose levels that ensures good germination. Detrashing should be avoided in the nursery plots. Spaced transplanting technique is also important. For planting 1 hectare, a 50 square meter nursery plot can be selected 1 month in advance to planting. In this, single bud sets can be planted at 600 to 700 per square meters. 4 to 5 weeks after sowing the sets, the seedlings can be uprooted and transplanted in the main field at a spacing of 90 by 90 centimeters. Before transplanting, the roots of the seedlings should be dipped in a solution containing 0.1% carbendazim. Initially, 2 to 3 irrigations can be given at shorter intervals for quick and better establishment of the seedlings. Polybag seedling transplanting involves the use of polythene bags of size 6 by 4 feet with small holes made at the bottom for effective drainage of water. A pot mixture containing sand and farmyard manure is filled in these bags up to 3/4 height, and single bud sets are placed in them such that the buds are on the side. The polythene bags are then arranged in a raised bed and watered daily in the morning and evening with the use of a rose can. 30 to 40-day-old seedlings can be transplanted into the main field after removing the bottom polythene sheet. 12,500 seedlings are required for planting in an area of 1 hectare. The tissue culture method is highly suitable for the rapid seed multiplication of new varieties. By adopting the meristem culture in this method, disease-free seed material may be developed at a faster rate. The micro-propagation technology in sugarcane provides various advantages, the most noteworthy being the rapid multiplication of new varieties. Plants produced through meristem culture are free from diseases and pests. The use of disease-free seed material ensures a yield improvement of 8 to 10 tons per hectare with an improvement of 5% in juice quality. Effective varietal scheduling is possible, and the field longevity of the variety can be sustained. The Sustainable Sugarcane Initiative uses sugarcane bud chips for seed multiplication and distribution. This method reduces the bulk of cane material, eliminating about 80 to 90% cane, facilitating easy transport and handling of seed material. The use of healthy buds eliminates diseased and infected seeds, transmitted diseases, and keeps pests at a minimum. It is also a relatively less expensive and labor-saving technique. This is a reliable method for the multiplication of breeder seed, as well as promising seed stock. The cane, after taking bud chips, can be well utilized for preparing juice, sugar, or jaggery. The methodology for preparing bud chips for seed multiplication follows a particular sequence. First, a healthy cane is selected. The cane should preferably be 6 to 8 months in age. However, if it is aged, the bud chips from the bottom 1 meter portion should not be taken. The bud chips should be manually collected using a chipping machine and then dried in shade. A solution consisting of 0.1% malathion and 0.1% carbendazim should be prepared and the buds dipped into this pesticide solution for 10 minutes. After this, they should be removed and dried in shade. If they are to be transported, they must be kept in perforated polybags before packing into corrugated paper boxes. The methodology involved in raising a nursery using bud chips involves, firstly, the preparation of a homogeneous mixture with equal quantities of well-rotten compost or vermicompost or pressed mud and coir pit. Seedling trays or pro trays may be used for this. Then, the bud chips are planted in upright position in the seedling tray and watered lightly. The seedling trays are stacked and covered with tarpaulin or a polythene sheet for 5 to 7 days in order to make the bud chips germinate faster. After emergence of sprouts, the seedling trays are arranged in a mist chamber or net house and regularly watered with a rose can or through mist irrigation. 1% urea solution is sprayed on the 15th and the 25th day after planting, and control measures are taken against the incidence of insects, disease, and deficiencies. The medium around the bud chip is lightly turned to ensure better germination and growth. After 4 to 6 weeks, the seedlings are transferred together with the mass of medium to the field and transplanted into small pits at required spacing of 150 by 60 centimeters. In case of varieties with high tillering, row and plant distances must be altered. About 4,000 to 5,000 seedlings can be accommodated per acre. For wide row spacing of 5 to 8 feet, suitable intercrops like soya bean, onion, tomatoes, etc. Drip irrigation has been found to facilitate a higher yield. The experiments at SBI, Coimbatore, revealed that transplanting the bud chip seedlings improved the tillering and yield of varieties. At the Sugarcane Breeding Institute, field establishment of transplanted seedlings was 100%.